Good day. My name is Brian Smith, and I'm a student at Full Sail University, where I'm working for my master's degree in mobile gaming. There, I wrote an application for one of my previous classes called Treasure Hunter, and I've augmented it to take advantage of GPS, being able to find where you are in terms of where you are on Earth, and also, too, making use of the accelerometer to identify if you've actually shook your device. What I'm going to do now is I'm going to take you through some of the core elements of the Treasure Hunter game, and so you can see how it then ties and fits together with some of the enhancements that I've made. So with that, I'm going to share my screen, and probably desktop is good. And let me give you just for a short little tour of the Treasure Hunter game itself. So this is the game here. I'm just displaying a green field scaled to the device. We've got some buttons across the bottom. For the actual the GPS and the shaking business, I would have you walking into your backyard, setting one corner, and then moving over and setting the other corner of a rectangle. But we're not going to do that part of the demonstration because we're inside the house right now. Just FYI, here's the credits. Easy enough. And then anytime you can click and view your inventory. And right now your bag of holding is empty. So the hint is you can tap or tap on the field to dig for treasure, or of course go in your backyard and shake as you walk around the backyard looking for treasure. But the tapping on the screen is the shortcut for that. And so here we are, just digging away, and you can hear there's maybe a little bit of a noise, a ding sound, like a gold coin dropping when you find a treasure, and there's just a hole dug kind of sound if you don't find anything. And then you can view your inventory, and you can see now you've got a sorted list of inventory in terms of the quantity, and then sorted on down. And you still have 160 treasures to be found on this. Now, the other thing I want to just show you real quick before we get into the code that supports this is I have a little, I don't know if you want to call it an Easter egg, but I call it a debugging routine. If you click in the upper left, lower right, upper right, and then lower left corners, it turns on debugging. So every time I refresh the screen here, I show you the red dot is where there's a treasure. So if I click on that, I'm guaranteed to hit treasure. And of course, where there isn't treasure, I can click on that. So it's just a way to be able to, for me to more quickly get to the end and find then all the treasure. So I get a message here saying, hey, you found all the treasure, congratulations. Otherwise, it's the amount of treasures still yet to be found. It's a little bit of a debugging kind of tool or Easter egg or whatever you want to call it. So that's the game. Let me take a look at some of the code to actually make that all happen. So I've got the main activity in Android Studio and a base surface, and that's where I'm drawing everything. Every time I need to refresh the screen, I'm drawing on that base surface. And so here in the onCreate, which is the called when the surface is first created, I am working with my context, and I identify the surface, of course, being able to identify that surface, so I get a object related to that. I force portrait mode, and then I set up the buttons for listening. These are the 4 buttons that you saw at the bottom of the screen, and I set up listeners for those. I read in then the bitmaps for the field, which is that field of green, and then the hole, which is the bitmap for the hole. And not yet, yeah. Anyway, so in the surface, base surface, I'll get to that. I do some more work with those objects, but basically I read them in here. Then this is the work for initializing the sensors and accelerometers and the GPS, and I've got that covered in that code covered in a separate video, so I won't even bother to work with that. Here is where I do monitor for the on-click, so in case the buttons happen, and so here's where I take a look at the inventory and the credits and just display messages to the users, and I will evoke some functionality on the surface. For example, taking all the items that I'm currently holding and converting them into a string, so that it keeps the button logic here nice and simple. And that is about it in terms of the functionality that is unrelated to the accelerometer and GPS. So let's hop over to the base surface, and this is where the lion's share of kind of the game all takes place. A lot of variables that I keep track of. I've got my bitmaps that I define, and I've got fields that hold the original bitmaps, but also scaled versions of all these, because as you see below, when the surface is created, I'll know then the canvas width and canvas height, and then I scale everything to fit that. So no matter the size of your device, it will fit and scale properly. It was not part of the original exercise, but I added sounds. So I've got a media player for that. I have some toasts for some debugging and some events that go on. Um, I have some paints. This is largely for the debugging, all the different paints that I have here. So just the color and the circles and different, different things as part of the debugging um, that I do. And then I keep track of the treasure items in a lot of different array lists. And the reason is I want to keep them as small and short as possible. So as I'm looking through them, for example, I'm trying to find that if a new hole being dug is going to find a new item, I don't want to be searching through all of the items, even ones that have already been found, when I only want to be searching for those items that are still buried in your field. And so I break things up into smaller little buckets. So when I'm working with those buckets, I'm faster and more efficient. And then information related to the GPS and location, then my debug antics, I call it, which is that the quadrant kind of selection to be able to turn on the debugging. The constructor, obviously very important for the base surface. And then when the surface is created, I get the information about the surface. And now, of course, I've got the canvas width and height. So I can start doing some great things with that. First thing I'm doing is I'm loading the treasure. So I'm reading in. I've got a routine called load items, and I read that in from this items CSV, which is right here. So it's just a list of all the different treasure that's available that's going to be buried out in the field. I then bury that treasure, and then I sort the treasure by XY location or by Y location in ascending order. So the treasure that is closer to Y being 0 is at the start of the list, and the treasure with the Y being down at the canvas height maximum would be at the bottom of that. And the reason I do that is just for efficiency's sake. So as I'm searching to see if I found this treasure, I work from the top of the screen down, and if I've gotten past where that, so if the XY location or the Y location that the user has selected, if I'm past that, then I know there's no possible way that I could be searching for that. Now, prior to that, I'm doing a distance kind of search, which is a little bit math intensive. So really I wanted to, on average, right, if the user is selecting generally in the middle of the screen, or let's just say on average, what's going to happen is I'm only going to have to search through the half of the remaining items to be found and doing this distance kind of logic. So again, I do a little bit of sorting up front, and I do that once and then done with it. And then the searching for it could be is more efficient. And of course, I could have done that with the X also, but I decided just to do it with the Y. Just it's good enough for this environment. So here's the business where I'm scaling the hole sizes and different things based upon the canvas width and canvas height, scale the field, scale the hole, and then I draw the images. So these images, they're normally drawn from the upper left-hand corner. And what I want to do is I want to find out where the middle is. And so I do some calculations to find in the middle of these different, the holes and the circles that I'm actually drawing out there. Prepare the toasts, prepare the paints for the toasts, and then also for the colors and the shapes that I'm printing off and debugging. And then I say, we are ready, and let's start drawing this thread. So a lot of preparation, both from now that I know the screen and the canvas size, I can do a lot of the mathematics in terms of scaling, but also too for optimization so that in the future, the program can run as efficiently as possible. So then just, here with the on touch, this is basically, kind of everything happens here in the normal game. Where you touch becomes that XY location, and then we dig a hole there. It's, let's say, that simple. But of course, beyond that, behind that is a lot of other things that are going on that I'm going to take you through. So here's the on draw. So every time I've invalidated the screen, every time I've said, ooh, I've changed something, a hole's been dug, and I want to refresh the screen, I call invalidate, and then this on draw happens. And basically, I'm looping through all the hole locations, and I'm drawing those holes that are dug on the screen. But if we have turned on debug with our little Easter egg kind of hunt, if we've turned on debug, then I'm drawing some additional things to give the user a little extra information. And then another little bit of debugging. If you do have the GPS turned on, basically every time you shake, I draw a blue dot on the screen just to kind of show exactly where that GPS location is as it gets then mapped into the X and Y location on the screen. So a little bit more debugging, but really the on draw is basically very efficient, only looking through the remaining whole locations or through the whole locations and displaying where all those are on your field of green. Okay. The other thing I wanted to show you then is the dig hole, which is, okay, you've pressed a location. Now we say, hey, dig a hole. Of course, you can also shake your device if you're doing the GPS and accelerometer. And the same code, dig hole, is called with the X and Y location of where you are. I work with sound, so I basically make sure that um, I stop any previous sounds. I'm not overriding or overloading that. So I make sure I'm stopping all those previous sounds. And then, seeing if we're doing any debugging. And then I only need to make the call if an item has been found. So if we have dug a new hole and we have one or more found new items, then we do the sound effects. So we have to make sure the sound effects is either the hole digging, which is a miss, or the gold coin, which is the dig. And as long as we have found some items, then I add those items into my inventory list, and then I sort that inventory count so that if they do then say, hey, I want to do, what is my inventory, then that is all sorted for them. It's a bubble search. So basically, if you're adding one thing in, going through the bubble search, it'll just bubble to where it needs to go. And so it's a fairly efficient sort with that. And that's about it there. So then the rest of these are basically just kind of routines to help me manage the items, load items, reads in from this items.csv. Here's that sorting the treasure by the Y location for efficiency's sake while I'm searching every time the user digs a hole. Sort by the inventory count is used for the information that's displayed to the user when they select the inventory, so that the items that they have the greatest number are bubbled up to the top of that. Bury treasure just buries the treasure in a random location on the map. A new hole is where you dig this new hole. Items to strings, again, to kind of simplify the button. So I just use this to convert all the different sorted items into the string and have that information displayed. So it's relatively simple. Again, just kind of working with the lists. I just wanted to show you the new hole. So it's the new hole digging. Basically, I'm just looking through all the different inventory items that are still there. And here's that where the Y location, this is the Y location of the hole that was dug, or basically the X and Y location where the on touch event happened. If that is greater than or equal to the location, and this is the whole radius, so I just make sure that I'm it's between this band. So if the location is between this band, then I start doing kind of the mathematics in terms of trying to find right here, right? Trying to find if the on X, basically on the X axes, if the on-touch location for X and Y is within a certain radius of of where the actual treasure is. So again, this math is a little bit tougher, especially on a handheld device, and so I wanted to minimize the amount of times I actually got into there. So, but if it is, we found a new item and we want to add this to the new items, we remove it from the inventory list, and then the item size, of course, is equal to the number of items that we have discovered. So again, kind of just good, clean programming fun. Sorry about that. Then just looking at the other things, the sort I told you about, loading items, just reading from the the raw file. So anyway, it's that is really the lion's share of what goes into this fairly simple game. But as I mentioned before in one of the other videos, it's fairly simple right now, but it's got the potential for being really, I think, very exciting if I give the user the ability to not just have random treasure that is buried there, that's fun enough, but to be able to actually then set their own treasure and then have clues to where the next treasure is. So you could have this treasure hunt not be just for, it could be leading people from location to location to location on kind of an Easter egg hunt through your backyard, or Easter egg hunt through a football field or through a park. And as the kids or as the adults got close to where they think the treasure should be, they start shaking their device and they'll be digging holes. And of course, if they haven't found it quite yet, they won't find anything, but they dig holes and all of a sudden, ding, and they found their hole. And then another message will say, congratulations, you found that, but here's your clue to the next place you need to go. And so it's a work in progress, as it were. Now, as part of the class here, let me stop the sharing. What I'm going to do is I've got 3 questions I want to answer as part of this class with Full Sail University. And the first question is, did the material you learn this week meet with your expectations? And there was 3 things I learned. There was unity test. With Unity, there was the test runner and actually getting that up and running. There was also the accelerometer and the GPS. So let me just take those in order. The test runner is, yeah, wow. I mean, I learned a tremendous amount with that. I, by the way, had a lot of difficulty in getting that working in the way that I thought it should work and with the caliber. And I had to basically refactor my code, as you saw, to make it work. So it was extremely important learning for me, because otherwise I would have kept going down a certain programming style and not done the right kind of thing. So that was a really useful exercise for me, was to force me to use something like the test runner in Unity to do the testing and to learn about how, yeah, anyway, how to write my code to better enable it to be tested in an object-oriented kind of environment. So very useful. Accelerometer, I've done programs in the past with the accelerometer in Android Studio, so that wasn't new and it was fairly easy for me, but I've never used the GPS. That was tough. And again, I had to use tutorials and really learn about that. So that was useful. So yeah, the material definitely met my expectations. Probably the only thing that disappointed is maybe too strong of a word, but for my capstone project, I want to be working in Unity. So I would have preferred to have tried to exercise the accelerometer and the GPS in Unity, so that I could grow and more learn the Unity kind of environment rather than stepping back to Android Studio, which I've been programming in lightly over the past about 5 years. But no matter, I mean, it's all good technical information and I don't mind learning, but that was just something that didn't quite meet my expectation. It was just a shine less than that. Was the topics useful? And again, the Unity test runner, wow, that was extremely useful, and it is always useful in learning new techniques, new technology. And the thing that is really important, especially for the mobile gaming and mobile development, is making use of these gizmos that have all these additional features in terms of input. And it challenges me, to not just think of touch, 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 of actually doing other things to be able to have things happen. As I was thinking about, what input devices could I have working for my capstone project, the World War I Flying Circus, and I was thinking about, what if you'd yell into the phone that, taka 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 taka, and the louder you were, the more damage the shots would be, or something like that. So a lot of different thoughts went through my head. So it's challenging me to think in different, more critical ways about what I'm doing, and that is always a good idea. The last question is, was this framework useful for this project in terms of your capstone project? And again, Android Studio is not going to be most likely the framework for my capstone project. It's going to be in Unity, and so for that it was less useful, and so be it. It was less useful, but always good to learn things, but less useful than if it would have both projects, let's say both of the project one and projects two would have been inside of Unity. I would have found that for me um, more in line with where I want to go with my capstone project. But of course, for me, it's better to dab with multiple different IDEs, frameworks, so that I'm smarter about the broader issues, and then focus in on Unity. So not a bad thing, but just from my point of view, it was not as useful as sticking around with Unity. So with that, I hope you enjoyed the quick little tour of the Treasure Hunter. So it was based upon a project that was done for Professor Chu previously, but with all the enhancements for the GPS and accelerometer, giving it a kind of a rebirth and turning it into something that right now it's not quite anything that's really super compelling or super fun, but giving the mechanics or the framework so that I can turn that into something super fun and super interesting in the future. So again, thank you for the opportunity. If you have any questions, please feel free to ask.